And now, what is this dataset about? Well, that's a classic dataset from actually the UCI machine learning repository, which I encourage you to have a look, because indeed it is a website that contains a lot of datasets on which you can practice. And this one is actually called Combined Cycle Power Plant, and it consists of trying to predict this dependent variable, which is actually an energy output. And don't worry, you don't have to understand how energy works or how the physics of this dataset works. The only thing that you need to understand is that we want to predict this dependent variable, which turns out to be an energy output. And we are predicting this dependent variable with these 4 features here, which are first, the ambient temperature, second, the exhaust vacuum, third, the ambient pressure, and fourth, the relative humidity. All right, so that's only what matters here. You have to see it as, a general data set where you have several features that you're going to use to predict that dependent variable. And as you can see, the condition, in order to deploy our regression models on this data set and the future data sets you'll be working on, is to have in the first columns the features and in the last column the dependent variable. All right, that's all that matters. If you have a data set like that, which has no missing data and no categorical data, well, you can deploy each and every single one of these regression models by just having to change the name of your dataset. And if your dataset has missing data or categorical data, you just have to go to your data preprocessing toolkit to take care of this, and then you can deploy these models. All right, so now time for the demo. I'm going to show you how we're going to quickly and efficiently plug and play each of these regression templates by only having to change the name of the dataset, and then I'll show you how we will quickly identify and select the best regression model for this particular dataset. All right, let's do this. So our first step here will be to create a copy of each of these files, because these are all in read-only mode, because this folder was shared to you. So since all of you will access it, you can of course not modify it directly, but in order to modify it, you just need to create a copy in your drive. And to do this, well, we can just do a right click here and then make a copy. So we're going to do this for each of the regression models here. Let's do this. Make a copy for multiple linear regression, then make a copy, then random forest regression, make a copy, and finally support vector regression. And there we go. All right, good. So we made a copy of each of these regression models, and the copies should be either on your main drive or in this Colab notebooks folder. And well, as you can see, they are on my main drive. So you will actually very easily find them. And now what we're going to do is open each of these files in order to proceed with the demo. All right, so I open first multiple linear regression, then I'm going to open polynomial regression, in the same order as the one we used to build our regression models, then support vector regression. Once again, you can either open them with Google Collaboratory or Jupyter Notebook or even Spider Anaconda, because I also gave you the folder containing all these codes and the dataset right before this tutorial in the article. So then let's open decision trees. And finally, well, random forest regression. All right. So actually, let me put it like that, the same order. Support vector, decision tree, and random forests. All right. So now we have all our regression models open. I'm first going to show you the code templates one by one, and then we will deploy them on the dataset, and I'll show you how to quickly figure out which one is the best model. All right, so starting with multiple linear regression, let's see the different steps. So we start by importing the libraries. Of course, that's the first step of the data preprocessing phase. Then we import the dataset, and as you can see, I made it super generic, meaning that the only thing that you have to change is actually the name of your dataset here. That's why I specified in capital letters so that you can't miss it. Enter the name of your dataset here, and we will actually do that in a few minutes. Then here you have nothing to change, of course, because this automatically selects all the columns except the last one, therefore your features, and this automatically selects the last column, meaning the dependent variable. All right. Then we split the data set into the training set and a test set. Of course, here that's very important to do this because since we want to select the best model, well, we need this test set in order to evaluate the performance of each of them, in order to compare it and select the best one. So we have to do this step absolutely. Then once we have, well, the training set, we will train our model on the training set. Then we will predict the test set results, to have a look at the predictions and compare them to the real results in y-test. And then finally, we will evaluate the model performance. And here, I don't want to scroll down now because we will discover together a bit later the code to evaluate a regression model, with the R-squared coefficient. All right, so that's the code template for multiple linear regression. And as I told you, and as you see, it is super generic because for any of your future datasets, provided that they have in the first columns the features and in the last column the dependent variable, and also provided that they don't have missing data or categorical data, well, the only thing that you have to change within this code template is just to enter the name of your dataset here. And that's it. By just doing this, you will be able to evaluate your model with a relevant metric.